in rage. We got the idea that obscurity is something to be mindful of. Like some things that maybe you gloss over when you're practicing maybe could come to the forefront when you're taking a test. All right, so that's something we want to be careful about. All right, so and when you do take the test, there will be a question on the limit definition of a derivative. You will have to do one problem, kind of along the lines of the exit ticket, where you have to go through the limit process. All right, but just like yesterday, it's a question of, well, but what kind? Is it going to be a polynomial function? Is it going to be a trig function? Is it going to be exponential? Right? It's not going to be too crazy. That's one thing I can promise you. You look at this and say, well, but yeah, that's the question. Like, but what about this one? This one was actually it's not that bad because the process is consistent regardless of what type of exponential function. Right? The first thing you want to keep in mind though is that -3 is irrelevant. Because the derivative of a constant is what? 0. So that's going away. All right, so I don't have to worry about that. The 4 is also a constant multiple. All right, so save this for later. Because one of the things we've learned throughout the unit is that if you have a constant multiple, a scalar multiplier, that you can take the derivative of the parent function and then multiply by that constant multiplier later on. All right, so really what I want to just focus on is y equals e to the 2x plus 5 with all those without all those extra trimmings. All right, but the important thing to keep in mind is when I say save for later, you got to save it for later. You can't forget about it, because if you forget about it, you're going to be off by a factor of 4. All right, so and that's the biggest thing that goes wrong typically. So I'm going to apply the limit definition. So the limit as h approaches h approaches 0 of e to the 2 times x plus h plus 5 minus e to the 2 to the x plus h all over h. When you're applying the limit definition, you got to be mindful of what the goal is. We got to get rid of the h. The h is what's causing the limit to not be solvable, I'll say. Because, yeah, it's going to exist. It's just a question of if I could just get that h out of there, things will start to play out a little bit nicer. All right, so I'm going to clean up my exponent. Limit as h approaches 0 of e to the 2x plus 2h plus 5 minus e to the 2x plus 5 over h. All right, so all I'm doing is applying the distributive property. I just ran through with the 2. All right, so that's just algebra 1. All right. The next step is the crucial step. All right, because what I want to be able to do is simplify this down so that I can apply a rule. Now, I know that I could break up the exponent of an exponential function based off of plus and minus signs. All right, so looking at this, I see that I have almost the same exponent between my first exponential and the second one. I could actually make them the same exponent if I rewrite it as 2 to the e to the x, I can't talk, e to the 2x plus 5 times e to the 2h. All right, because it's basically keep the base, add the exponents, but in reverse. All right, I just chose to break it off at that plus 2h. Right, there's an intermediate step you could show if you want. E to the 2x plus 5 plus 2h before breaking it off, but that's not necessary. All right, I mean, unless it's necessary. If you think it's necessary, then it's necessary. All right. Now I have a common e to the 2x plus 5 in my numerators. You'll notice that it does not contain an h. If an expression, a factor, does not contain an h, it doesn't need to be in the limit. So I'm going to pull it out of the whole thing. So we're almost there. Like, it's almost an identity. Very, very close. This is a 2h, so the bottom has to be a what? 2h. So I'm going to multiply the bottom by 2, but I can't just multiply the bottom of a fraction by 2 without doing what? Multiply the top by 2. Now I can multiply any part of the top. So I'll just chuck it right out there. Now this expression goes to 1. And I'm left with 2 e to the 2x plus 5. Is that my final answer?
No.
No. What do I need? The 4. Bring that back in. So I get 8 e to the 2x plus 5. Now, as far as notation is concerned, we started off originally with f of x? Yeah, so f prime of x. The 3? That went to 0. That was irrelevant. We ditched that immediately.
And then you just brought back the 4.
And then just brought back the 4 from the top. The one that was saved for later. We saved it for later. Here's later. Once we apply the limit, later has arrived. Multiply that result. This was that result. Multiply that by 4, and you have it.
How'd you get e to the 2h minus 1? Like where'd that go?
Where did it go?
Where'd that come from?
Oh, when you factor out the e to the 2x plus 5, that gives you e to the 2h here. When you divide this by e to the 2x plus 5, divide anything by itself, it becomes a 1. All right. And so the h just stayed there.